Hello, this is Mr. Gribble. This is the second video about the Daylight project, and if you haven't seen the first video, you should go watch it because what we did in that video primarily was to create this Excel file and have this data. I've done a little bit of stuff here to the file since I ended the last video, but what we're gonna do is this was just a graph, and while Excel can put in trend lines, which are lines of best fit, it doesn't have one for sinusoidal regression. Like, it can do polynomial, and if we increase the order of the polynomial to like a lot of orders, so that would be like a, like an x to the sixth, what that means, polynomial, it could do a decent-ish job of coming up with the function there. But because we know that the sun goes up and down at fairly regular intervals, it's periodic, and so this is going to be a sinusoidal function is going to be the best one to use for this. So we can't do it in Excel. So I'm going to actually get rid of that. Ooh, I don't know how to get rid of that. I guess I have to click it and delete it. Question mark? Yeah. Okay, so what we're going to do then is I'm going to look two different ways that we can come up with a function here. We could actually do a lot of it by hand if you wanted to, right? You could find, you could look for you can look for a minimum value. So here's a minimum value here. I mean, this would be really hard to do by hand because we don't have data really. We have one full period of data. We have 365 days. Like, when does it start to like repeat? Well, a period for sure is 365 days, or 365.25 days, because there's such thing as a leap year. But we don't have, like, this kind of a little bit imprecise based on our method of doing this, because we used averages, and in this year, February didn't have 29 days. So this 365 days is the observed period of our data. Remember, if we want omega, it's 2 pi divided by 365. And then the amplitude we can get by finding the maximum value, which was here and here. If we take this 16.37 and subtract 7.5, not 16.37, whatever this is as a value. So I'm gonna paste this as a value, and then paste this as a value, and then multiply them by 24. So this times 24. And this times 24. If we want to know what the amplitude is, right? It will be the maximum minus the minimum divided by 2, and that's what we should get for our A value when we actually do this in a minute. And then if we want to know what the vertical shift was, or this would be like kind of the B value in the way we talked about the standard form of a sinusoidal function in class, but the vertical shift anyway, the location of the midline, basically what you can think of it as the average amount of daylight over the course of the year. It would be, when we find the average, we take the maximum. I'm wrapping them in parentheses to make sure I don't do any order of operations wrong, and then divide that by 2. And so that would be our vertical shift. So okay, we can mess around with the period and stuff, and it looks like we'd want to use optimally. We'd want to use negative cosine, but there's two different ways we can kind of do this with like graphing utilities. The first one I want to show real quick because it's inferior is a graph on a graphing calculator, and I've already input this data. This data right here, like I used for January, I used 1, February 2, and then December was 12, and I input this data. Don't worry about why I have all these things copied. I was messing around with it. It's just this same data. So it took a while because I had to type it in, and I typed it into the 6 decimal places that are showing here, even though if we actually look at what the data says, there's quite a more precise actually than just the 6 decimal places that we're showing. But again, we're taking the average, so really how precise is this anyway? So if you go back here, did it just turn off? Yeah. So if you want to input the data, you go to Stat, and you'll hit Edit, and then you'll have these lists. Notice I've already put it in. In L1, I have the numbers 1 through 12, and then in L2, I have all the data that corresponds to those months. And then what we're going to do is we're going to plot this data. So we're going to hit second stat plot. Second y equals, that's stat plot, and I'm going to turn stat plot number 1 on, so it's off right now. If I hit enter and then go, it's on right there, so I hit enter again. If I click on these, does it move? No. And then this is just like a scatter plot of points, and my x list, my x values were in L1. Those are basically the months of the year, and then my y list was in L2. And so what I can do is if I hit enter right now, or actually if I hit graph, it's going to plot this data. It's all out of whack. Also, one of these data points is super wrong. Let me go back and look at the data real quick. Yeah, it's not 1.085. It's this was 7, so it's 16.085 8495. So if I go back to graph, okay, it's all out of whack, right? This makes sense because that only goes up to 10 and that goes down to 10. So I have my maximum values. If I want to see this kind of, let's do our x-min. X-min's 0 and x-max we'll put as 12 because that makes sense because I don't have negative months. Y minimum will make that 0, and the y max, the highest y value I had was 16, so we'll put like 17. If I hit graph, okay, now you see kind of the data. In fact, why don't we make the x values, why don't we make one more so that we can see all of it. Oh, that's not the right one, oh, whatever. Make this 13. Okay, so there's all the data. And if we want to do a sinusoidal regression for this data, it's the same, it's the same curve, it's the same points. And you can do that on these calculators. You hit stat, and we're going to do a calculation, and we're going to use synreg. Now, depending on the software of your calculator, it's going to show you this menu, or it's just going to enter synreg in your compute screen. This iterations, how your calculator does a synreg is it does something called a method of least squares, and if you have a higher number here, you can only input a number between 1 and 16, like a whole number between 1 and 16, including 1 and 16. And the higher the number, technically the more precise your regression will be, but the harder it will be for your calculator to do that regression. It gives you a default value of 3 because that's fine. L1 and L2, X list, Y list, those are where we have our values for X and Y. And then period is, we could guess what the period is here. We happen to know what the period is, and because we have inputted 12 months, not 365 data points, our period we would want to put 12 there. Well, actually, we want to put 12 there. But we don't want to do that at all, because you don't have to do a guess. But what we do want to do is make sure whatever equation it does generate, we want to have it stored, and where we're going to store it is in the variables. So this button here, vars, is a variable button. You hit variables, and you go to y variables, and then function, and then y1. And then if we go down to calculate, what it's going to do is do a sinusoidal regression for x values of this, y values of this, and store that equation in y1. And if we hit enter, it does it and gives us these values. So actually, now notice also it's using sine, so there's going to be some differences. But if we go back and look at what we kind of predicted based on our Excel, the amplitude that we came up with was the 4.38, which is close. Again, this is using, we don't have necessarily a maximum. That might be the maximum in our data, but the way it's curved, like the way the calculator thinks it's curved, can cause a different minimum or a different maximum or whatever. And then the vertical shift, the vertical shift was 12.2, and this one was 12.17. So it's close-ish. Now this is not in an we thought about this, and right away we're like, oh, it's a negative cosine, and yet here's a graphing calculator using sine, which means it's using a fairly large phase shift, and it means this. Right now this number doesn't mean anything to us because we're not exactly sure how to interpret this function. But if we hit graph, it graphs that function, that sine function that it came up with. It's graphing it right there, right on top of it, and it looks pretty good, right? And so that's interesting. But if we go back and we actually look at what the thing said, I don't know how to show the rest of this. I guess I do. This phase shift, like what does this mean, right? There's a phase shift. Obviously, okay, we all know intuitively that January 1st or December 31st is not the shortest day of the year, right, in the Northern Hemisphere. If we're talking about Southern Hemisphere, that would be showing up as the longest day of the year, I think, unless I have my, like, geography, astronomy all completely backwards or wrong. And so there must be a phase shift, and we got to think about what that phase shift is. So that's something to think about. Anyway, we can use these numbers here and then continue working. Or a better way to do this is to use Desmos, because it gives us more freedom and a little bit more precision, actually, as far as like our what it comes up for our regression, our line of best fit. So I'm gonna open Desmos, and I'm signed into my Desmos because this might be a cool thing that I want to save for later. So this is just a blank Desmos graph, and what I'm gonna do is go back to Excel, and I organize this same data right here. I organize it in this orientation, and I'll show you how I did it. I just typed the numbers. I typed 1, 2, 3 right here. I think you could do it with 2, but if I type that, I've established a pattern where I'm increasing as I'm going down, and I'm gonna drag that down, and notice right next to my thing it says 7 to 8, 9, 10. I'm gonna have 12 months, and then I want this data. But I want it like oriented down, bottom to bottom instead of left to right. And the way you can do that is by doing a transpose copy. So, or a copy and then a transpose. So we hit copy, and then if you right click here, you can hit a transpose paste. So instead of it being horizontal, it's going to go vertical. And the reason I want to orient this is because I can actually copy paste data from Excel straight into Desmos. And the benefits of doing this is A, it doesn't take me forever to type in these values into a calculator, and B, like if I am trying to be precise with my stuff, it's going to have this entire level of precision. This precision will mean a lot more if you do the option where you have all 365 data points lined up. However, it's harder to paste into Desmos that way. I think Desmos has a limit on its tables of like 50 or something. Well, that's what it was last time I tried this. But so I'm going to copy this and then go straight over to Desmos, and I'm going to just paste this in right into an expression, and it automatically interprets it as a table, which that's super nice. Okay. And that's that same curve, right, that we've been seeing. We see it there in Excel, and we saw it in the calculator, and right there, okay. That's my cat meowing at me. And so how do you do a regression in Desmos? Well, it's actually kind of cool. What we want to do is have a regression in terms of the y value, or a regression for the y values. So notice in the y1 column, I have those y values, and the way you get y1 is you type literally y, and then it automatically subscripts the 1. And instead of an equal sign, we want to use a tilde, which is next to it's a shift and then the button next to 1 on your keyboard. And then we're gonna type in just like a generic cosine function. Actually, it's a generic negative cosine function. It doesn't have to be negative. It'll be positive because it'll make that a value negative for us. And we'll type it in the same format that we're used to doing it in class, which was a times the cosine of, and then we'll say w is going to be omega, and then we'll have x1, so we're going to use our x values, and then I want to make sure there can be a phase shift, so we'll hit, like, I don't know, we'll call that b, sure, and then I'm going to have also a vertical shift, so let's make the vertical shift c. Now, the more, like, if I didn't want it to have a phase shift, right, it's gonna automatically try to put it as a cosine function that has no phase shift. But if I let it have a phase shift, then it's not gonna necessarily be right there on the x-axis. Like that is not the minimum. This is the minimum. Interestingly, okay. So that's like that's weird. And so what we've got here is some data that's kind of different than what maybe we expect it to be. And the reason for that is that this minimum is to the right of the y-axis, and the y-axis on our graph, on this like plane represents January 1st, or like midnight January 1st. This first data point is at the end of January, right? It's at 1. Like, so we shouldn't even, I kind of shouldn't be there. Maybe it should be like 0.5, and maybe we should have February's data at 1.5. But regardless, this minimum doesn't make sense because the shortest day of the year is also not in January. It's in December. It's actually on December 21st, which is the winter solstice. So our minimum should be over here a little bit. And this is a flaw in how we did the data here, and how we have the averages and how we labeled these. So actually, if I go in and I change all these, say I want to subtract 0.5 from all these, so that I can like kind of shift the data over a little bit. Let's see if this helps us at all. It shouldn't. I think this will just result in a horizontal shift of 0.5 to the left. 0.5 of a month essentially to the left. Ooh, something weird happened there. What did I do? That doesn't make sense. Get rid of this phase shift, and then put the phase shift back in so it doesn't. Whoa, what? Oh, that is very weird. I'm not sure why that's happening. Maybe I need to do a minus B. No, a plus B. Why does it do that? Minus B. So that's clearly getting them all, but not in the right way. I'm not sure what's going on here. Let me undo all this junk I did, because clearly that's not working. So it requires some playing with, is basically what I'm getting at here. So according to my sinusoidal regression here on Desmos, the amplitude is 4.2. So remember 4.38, and the calculator had told us it was 4.208. So it looks like we're using pretty similar methods here. Our B value, which is our phase shift, that's going to look different because the way we have this formatted, we've got it as the omega is like factored out, whereas this omega is multiplied in. So if I go over here, first of all, omega 0.512466766 is pretty close here. They just have negative because it's not even calling it a, it's not calling it a cosine with a negative cosine. It's not calling it a negative cosine. It's calling it a cosine of a negative like number. And then we've got, wait, did it call it? Yeah, that's right. Okay, then the B value, like if we divided negative 0.1600 by 0.512 something, we'd have, looks like we'd have this. No, that doesn't make sense either, because this shift is cosine. Oh, but B, why is it shifted 42 over? That doesn't make sense. That is very strange. Why would it shift that? Why would it choose that shift of all shifts? Maybe I can actually type in a shift of like 0.2. Because if I go and if I think about it, right, the winter solstice on December 21st, that's 10 days or 9 days maybe, if you look up the exact time, before the end of the year, right? So that is how much of a month, because I'm kind of in terms of months, which is not what I'm going to want at the end. I want to be able to input a day and get a time, a number of days, number of hours of daylight out. So, but 9 divided by 31, that's 0.29 of a month. So if I shift this over 0.29, that's the wrong way though. If I want to go plus 0.29, plus 0.29, I'm going to have kind of a better, it's not going to fit the data better, because again, my data, the way I computed it by those averages, clearly it's going to be flawed. But right now, I would venture to say that my function, having been shifted over to the left by 0.29 of a month, which corresponds to those 9 days, not like 9.5, 10 days, of the winter solstice being about 9.5 or 10 days before the end of the year, I would say that this green function in here is a more accurate representation of what's actually happening. Again, the best way to do this would be to literally input every 365 value into Excel, and it seems like that would be awful, but it's really not. If you create the file to start with in Excel, But if you get efficient with it, like I could even do we'll do the first 3 months right now. It's really not a big deal. In fact, if we do a sinusoidal regression on the first 3 months, we might get pretty close. Where'd the data go? It's scrolled over. So now I'm going to take the data from the second month and I'm going to put it right here. Oops. I screwed that up. Put it right there. And I'll put the data from the third month and put it right here. Data from the, not right there, I'll put it right there. Fourth month even, we'll do 4 months. Okay. Now the thing is though, is I don't want these hours and minutes, so learning from the lesson we learned in the last video, if we take this and multiply it by 24, scroll these down the whole way, well the whole way we did this for so far anyway, and then change this format of all these cells to just a general. What I would want to put into Desmos is this column and this column. So actually, why don't we just delete this column? Because well, that's not going to work. I actually have to. So, okay, this is a little bit more involved. So let me take these values, 120. If you don't know what I'm doing right now, like this is not a requirement for the project. It would just be cooler. So we're going to take these values and whoops, and we'll put them right there. Nope. Why did that happen? Oh, we don't want that. We don't want to paste just the values. So if I take these and I just try to, I don't know how many we'll actually paste into Desmos. So let's go to Desmos and then delete this and then go here and put them back in. There, look, see, now it's got like all that actually put in 120 values. And you might be able to do all 365 in one swoop for Desmos now. It had a limit before. But still, even with, so it wasn't able, it looks like it doesn't have quite enough values to get the sinusoidal regression just yet. So anyway, this is kind of the process here, and we'll talk more about it in class, but that's kind of where we're going here. And then as far as the requirements for what you're going to actually turn in, that's in other resources and not this video. So hopefully that does a good job of sort of explaining the starting of this. Really, well, actually not even the starting, like pretty much the whole way through as far as the computation side of it goes and the thinking. This has been a pretty long video, so I'm going to stop it right there. And if you have questions, just ask me.